If life was a Monopoly game, then Jens would have rolled high enough to go from chemistry to cybersecurity, but without having to lose 3 turns in jail, or as others call it, university. That said, he might still be considered a bit of a bandit, considering that he's already using Zig in production, which is also the title of his presentation. Jens, the stream is yours.
Hello, and thank you for having me. Here's a little about me, if you want to send me fan mail or something after the talk. Anyway, I will start with some words from Andrew himself. Please don't use SIG in production yet. Well, you can't tell me what to do, so my talk will be about how we use SIG in production. So, our company develop stuff for embedded systems. And by embedded, I mean barely embedded. It's still Linux. So it's developing for these is it's like systems programming, but some limitations. So the architectures used are quirky, usually ARM, but you can't assume it's little endian. You usually have to compile for a lot of different architectures. The memory we can use is limited because if you're doing normal systems development, you can pretty much assume you have an infinite amount of memory. Like you shouldn't, but you can. But here you can't because you will run out and your malloc calls will fail. So you actually need to handle it. Disk space is limited, which means you can't always statically link giant libraries. Anything over a few megabytes is, barely acceptable. These devices also have a limited stuff on them. So maybe we develop something for a set-top box, and it has basically only a BusyBox available. So if you're running a server, you want to see if your clients are connecting to you, well, you could run TCP dump to see if the SYN packets have arrived. But in these devices, you don't have TCP dump, or maybe you want to use Nmap to see if clients you're supposed to talk to are even up. Well, you don't have Nmap, so it's highly limited. Now, the only language until now that you could use in practice was C, because C targets every quirky architecture out there. C programs don't use a ton of memory. C programs are fairly small, and they're really the only programming language you can use in practice that actually cares about out-of-memory situations. Now, it's not perfect. A lot of C libraries just assume that malloc will always work, and they'll just call exit 1 when it doesn't, or just crash. So you're still limited. But now there is Zig, which it really does what C does in this area, but it actually does it correctly from the start, which is really nice. So I will start with talking about the first project we did, which we used Zig for. We were contacted by a Swedish industrial firm. They had security zones in their factory where you weren't supposed to go to unless you really had to, because there was hazardous material all over the place. And if you had to go there, you shouldn't be 5 people at the same time. It should be just the right amount of people that had to go there. So to solve this, they bought a lot of passage sensors. They're like tiny sensors you mount over your door, and whenever somebody enters the room, they would say, all right, somebody just entered. And when you leave, they would say, somebody just left. All right, very simple. Then they realized they had just bought 100 IoT devices, and IoT devices aren't really known for their excellent security track record. At best, they are developed by the lowest common denominator outsourcing firm. At worst, they are literally Chinese backdoors. So they would, to solve this, they put all their sensors in an isolated network without an internet access at all. Then they asked us to please integrate this isolated network to our security center. Fine, we can. So we added a little ARM computer, like a Raspberry Pi kind of thing. Not exactly a Raspberry Pi, but similar, which had an RS485 connector, which is like an industrial standard for messaging, like a message bus. And over this, we used the Modbus protocol to talk to their security center. The Modbus protocol was written in the 70s and is really old and really crufty. But it has one thing going for it. It is that it's so old that you really cannot hack anything through it. It's basically you get a message, hello, what's your current count? And we say, okay, 7 people have entered the room today. And they say, okay, fine. And then we get a second later another message, what's your current count? And we say 7 again, and so on forever. And the program we were supposed to develop had a lot of things going for it that made SIG a good choice. The first is that it was for a weird ARM architecture, and SIG is really easy to cross-build things. The second thing is that this was basically like a demo. We wanted to see if it worked. So we were just supposed to deliver a binary, basically, to check if it worked at all. So if I had to support this for years, then maybe I would have chosen C instead. But now I could choose SIG because I could kind of forget about it after it was done. So we delivered the binary to them, and it worked. And I've never heard from them. Oh, hell. Okay, now we're coughing here. I delivered the binary to them, and I didn't hear from them again, which is basically a critical success. Because if they had responded more, it would mean there was some bug or something. So I'm pretty happy with that project. Now, since this kind of proved that you could do something with it, we got another request, which was from a Swedish a Swedish like grocery store chain, and they wanted they wanted to have one store open unattended at night without employees. So how that would work is customers would go up to the door, they would verify who they were, the door would open, they would enter the store, they would grab whatever they wanted, they would go to the self checkout and leave. So that's nice. Um, so we were responsible for the door and the sign-in, like not the self checkout. Luckily for us, in Sweden, there is something called Bank ID, which is the Swedish e-identification system, and which is basically a certificate you install on your phone. And you use this to verify who you are. And I checked last night, I checked how many Swedes use this, and the answer is for all adults under the age of 71, 98.8 people of everybody uses it, which is pretty ubiquitous. And I checked out the groups that don't use it. They're basically people who live abroad but still are registered in Sweden, stuff like that. Like really everybody uses it. So how it works, okay, let's say I wanted to verify my identity to Loris. He would send me a QR code and I would scan it with my phone, and I would get a little pop-up saying, hey, the SIG Software Foundation wants to verify your identity, so yes or no. And I would say yes, and I would sign with my password. And Loris would get a call back from the Bank ID server, and they would say, oh yeah, Jens Goldberg just verified. Here's his a social security number. And now Americans might say, hold on, it just gives you your social security number. Well, it's not that secret in Sweden. You could pretty much, it's pretty much Googleable for everybody. I could check my friend's social security numbers just by in 10 minutes, basically. So it's not that big of a deal. Uh, in any case, our first idea was, okay, let's just print the QR code on a piece of paper and staple it to the wall next to the door. Like, super easy. That turned out to not work because every QR code is used for an unique transaction. So we needed a monitor. So we hooked a monitor to our little ARM computer. And if I had an infinite amount of time, I would have used KMSDRM, which is like the hardcore Linux, low level, how you put pixels on the screen on the modern Linux. But I did not have an infinite amount of time, so I used SDL. And to control the door, they had a REST API, so I just used curl. And that was basically it. And then we launched it, and it ran for a few months. And I'm happy to say we had 0 bugs, which I was pretty proud of. And our system was featured in the Swedish state television, local news for Värmland, which is not exactly a metropolis, but pretty cool. So I was happy with that. Note that the 2 projects we did were either limited in time or just a one-off. So now we have a 3rd project, which is actually a real big thing, in that we were approached by a Swedish public transport firm. They have these devices which count the amount of people entering on buses. So the reason you want that is obviously because you want to know if some route is overcrowded, or if nobody uses a bus stop, maybe we should move it, stuff like that. Also, a lot of municipalities in Sweden and in Northern Europe, they subsidize public transport. So every time somebody enters a bus, the public transport company gets some cash. So they are really interested in having a super accurate count of people, because as long as it doesn't work, they're instantly losing a ton of money. And they asked a lot of companies, and they saw this beautiful device you can see to your right, and their solution was either to install a server on the bus itself that you would use to communicate with this, which is not really realistic, or they looked at installing their software on the device and then gave up screaming after 10 minutes when they discovered how ancient it is. It is an ARM7. It is pre-millennial. That is, this was fabbed before 9/11. So basically nothing works. There is a really tiny amount of memory. And I got it, and I said, all right, let's try SIG. Let's try target ARM. Let's specify the architecture as this specific architecture, and wouldn't you know it, it just worked. I was really happy with that. Now, of course, there were a ton of other problems. The first one was integrating with account itself. They had a lot of ways of doing that. Like 80% of them were useless because they didn't give us real live data. They just gave us counts during the last 10 minutes kind of things, and we have to discover that instantly. The second choice, or the first choice was IBIS, which was apparently some German Deutsche Bahn integration thing. And it sounded promising. You'd send a UDP packet to a specific port, you'd get a count back. All right, fine. Then I tried to find documentation, and I found some. They were all very corporate-ese, with no practical information, and it was all in German. So I wasted like a day on that. Then I gave up. Then they had another really weird way of getting the data is that you specify an IP and a port in a configuration file, and the device would send you an XML every time somebody entered, which is okay. I can deal with that. I don't want to parse XML, but I can deal with it, Uh, However, we found out that on some buses, another third-party company had already used this feature. So we couldn't just, and it only supported one target. So we couldn't just boot them out or anything. Like we couldn't destroy their business. So we were left with nothing basically. So my last ditch attempt was to write a SIG program that opened a roll socket on loopback. I dumped every packet on loopback to a file. And I opened that file in Wireshark, and I could see how the internal IBIS daemon communicated with their internal counting daemon. And fine, I could pretend to be the IBIS daemon. Like, I don't know how the protocol works. It's some corporation specific protocol. So I could see that they sent like 8 bytes, random bytes, which I have no idea what they mean as a handshake. So okay, fine, I'll send those too. And I got a handshake back. And then I started getting events, and I could kind of quickly see how the events were shaped. Like this has to be the size of the event. This has to be the ID of the event. Most of them I have no idea what they mean, but one of them I could see, okay, this has to be the count out and count in. So I just pretend I am their internal IBIS daemon. I discard every event I don't understand. I just take the count, and it works. And then we got a much newer device from a few years ago, and I tried my hack daemon on the newer device, and that worked as well. So I'm kind of confident that this solution will work. Well, fingers crossed, it will. Anyway, with this information, we were supposed to send it to an MQTT broker, and that is basically a message protocol. You send. They wanted like a JSON. How many people exited this door during the stop? So I construct one, and I send it away, and that's it. Another issue with this is that it does not have a battery, so it always boots in 1970, and after it boots, it doesn't get internet for a while because the 3G router takes a while to boot. And I don't want to miss the first stop because I need the current date to send to MQTT. So what I do, I discovered that the buses had a GPS on board, and a GPS always needs very accurate time. So I just asked the GPS, hey, what's your current position? And it also gives me their internal time. So fine. The first thing I do is ask the GPS, what's your position? Take the time, set the system clock, and I'm done. So I'm currently working on this project right now, and there's like 1 day maybe left till we send a demo. So, but I'm pretty happy how it turned out. Now,
Jens, sorry for
yeah,
interrupting
sure.
you. Are you still on the passenger counting slide, or did you move forward?
I am still on the slide.
Okay, just double checking since it was
Yeah,
Firefox.
sorry.
No worries, no
I
worries.
will, I will go to the next slide right now. Okay.
Nice.
Why are we using Zig and not C? Okay. First of all, we are targeting a ton of different weird architectures. And you can do that with C. You just have to make your own C toolchain. That is a giant pain in the ass. Because let's say I want to parse JSONs. Then you need like libjansson maybe. Then you need to compile that for your weird ass architecture. And then you have like a collection of libraries. And when you get a new architecture, you have to build a new GCC, a new everything, and then all your libraries. And like you can kind of assume that some of these, 1 or 2 of these libraries will fail to compile on this new weird architecture you're supposed to target. Like it always happens. There's a giant pain. It takes ages, and it takes a lot of effort. With Zig, I can just, instead of wasting a day, I waste 10 seconds because I can just target the exact CPU and it just works, which is literally unparalleled. The second thing is performance, and with performance, I mean code size as well, and how much memory it wastes. And if your binary is small enough and efficient enough, it unlocks opportunities to simplify your entire architecture. For example, in one of our devices, it was partitioned in such a way that the system files had their own partition and it was sized so it was exactly the size it needed, plus a little extra space. So if we had used something with creates very bloated binaries like Go, we would have to put it on the log partition maybe, and then create like a soft link from user bin, like horrible hack or something. In Zig, the binaries are like 20 kilobytes. So we can squeeze it in wherever we want, basically. If your binary is fast enough, you can. If you have a slow program, maybe you want to host it in the cloud, and it's too slow or doesn't scale, so you need to put it on like 7 servers, and you need some sort of load balancer, and it's just a giant pain. But we don't need to, because it will always use 0.1% of CPU, whatever we do. And we don't need to put them in like Docker containers or anything, because it has no user space dependencies, which is extremely nice, because if you depend on user space, you can never be quite sure that your program will work after you've updated your system. You can never be quite sure that it will work on this new system, because maybe this new system has a slightly older version of glibc, and then it fails to start, and it's terrible. We get emails from customers who want a list of our requirements, and the only thing we have to answer is we want a Linux kernel that's been updated the last 15 years. That's it. So this real annoying email chain when we specify exactly what we need, we can just ignore it. It's really, really nice. The fourth benefit is that the Zig library has a lot of nice features which the C library does not. Which, for example, parsing JSON. It's every time you have to add a library, you add pain, because it will break. It will be issues with linking. It will be issues with dependencies. It will be just a ton of annoying issues. We wanted to create like a checksum, so we needed SHA-1, and so what do? You link OpenSSL, and you're in a world of pain. In Zig, you have SHA-1 in the standard library, and it just works, and it's so nice, so convenient. Now I know Zig's. We have not yet decided on how bloated our standard library is actually going to be. So maybe it won't have cryptographic functions in the future, but they're there now and they're very nice. So I like that. A fifth point is that I feel that Zig is a lot more dependable than C. And that's not just, it's not that I have less buffer overflows, because I don't really have buffer overflows that much. It's that the logic of the Zig program is it's clearer, and it's easier to see what's going on. and that's mostly because the defer and error defer are really, really nice to have, because error handling in C is a giant pain, and it creates a lot of terrible spaghetti code. So when I run a SIG binary, I sleep sounder at night. Uh, I don't really have any hard data or anything that it works, but it feels that way, and it's very relevant to me anyway. Now, SIG isn't perfect, obviously. There are issues, and there are issues which we share with everybody, and that's things like documentation. Now, I didn't add this here because like every SIG programmer has the same problem. It's not really specific for SIG in production. Now, it's not that bad because you can just look for. I usually look at tests in the standard library on GitHub, and that works quite well. Um, but obviously, could be better. It's really hard, I know, because if you change something you might have written a lot of documentation for, you just wasted a lot of effort. Now, what is a problem for us is that the compiler and standard library obviously updates. Like we can't really expect anything else because the language isn't done. So, but still, if you compile something, if you make software, and then half a year later the customer says, "Hey, we want an update," then okay, you got to spend some time getting your code compiling again. Now, this isn't really a problem, that big of a problem, because the changes aren't that huge. I fixed our unmanned store program, and it took like 20 minutes. The var args had been removed, so I had to fix the print statements. JSON had changed a bit. It's like 20, 30 minutes. It's not a big deal, really. And some things, when they change, SIG format takes care of it for you. Like when the way you specified you wanted C linking on external symbols, they changed the format. But I didn't have to do anything because the SIG formatter just rewrote it for me. So I'm pretty happy with it. The second giant annoyance is that the SIG does not have a built-in date support. I know there is a third-party library for this, but the problem is with third-party libraries right now is that they have the same problem with updates to the compiler. So if you run the latest compiler, your date library will start failing, and you have to fix that too. It's kind of annoying. The reason we need this is because we do a lot of integrations with a lot of stupid protocols, and protocols love having weird ass date formats, which we need to convert. And if you develop something new, like a hobby, you probably don't do. You won't run into all these dates all the time. Okay, so that is, I think, it. Yes, thank you.
Thank you very much. So let's switch to the Q&A view then. There we go. Okay. Is that a blank slide?
That is a blank slide, yeah.
Okay. Sorry for double for asking you about everything, also for interrupting earlier. But so just to give you a little bit of feedback. In the end, Firefox kinda behaved itself, but at one point it did go to black, and I had to like reload the page on my side. Not a big deal. It was only a moment, so don't worry.
Right.
But that's why then we were all a bit suspicious of Laplace. It's annoying.
I see.
Okay, thank you very much. So you have a ton of projects that are using Zig in production then.
This was the 3 projects I mentioned. We actually have 2 more, with theirs tiny, and it would have run out of time, basically.
I see. So while people think about questions, there was one earlier that I want to ask you. I wasn't tagged in it, but I'm going to ask you anyway. But before that, first, let's let me start with the usual question. How did you discover
Sure.
Zig, and when was that?
I think it was like, I know exactly when it was. I saw the Road to Zig talk by Andrew Kelly.
And
That's it.
it radicalized you.
It radicalized me. Yeah, it's like one of those ISIS recruitment videos.
Of course, of
Yeah.
course. So another question from me. You mentioned MQTT earlier. Do you have an
Yes.
opinion on MQTT versus zero message or zero MQ or nano message?
I only really know MQTT.
I see.
MQTT is, I think it's fine. It's simple enough that using a library, you don't have to use a library. It's like you open a socket, you write a struct, here is my handshake. You get a handshake back and you start using it, basically. Like learning a library is not really worth it.
Mm-hmm.
And I like that.
Okay. So, so let me repeat the question. This question arrived immediately while you were presenting, and it's from Alex Nask. So might not be he wasn't super serious, but I'm gonna ask it anyway. So you mentioned
Sure.
you can use C to do the type of embedded work that you do, but then you wanted to try Zig, and of course Alex asked the standard question that was in everybody's mind: why not Rust?
Because, okay, I've tried Rust, and I like to recompile my software all the time. Like do some edit, see if it works. And I built like a hello world, and it was abysmally slow, like ridiculous. So I said, okay, fuck this, and I deleted the compiler. That's it. Also, I don't think Rust cares about memory allocation failures. I'm not sure. I could be wrong. Could have fixed it, but I think they just crash, and I can't have that.
Mm-hmm. Okay. Oh, by the way, you know what you could do in the meantime? I have a couple of questions. So, can you maybe go to the first slide where you are presenting yourself? I think that would
Sure.
be so we can leave your contact info down there. Yeah, I think.
Sure. If you want to send me hate mail or anything, that's fine.
Okay, so one question from Firefox. So, aren't you worried that the Z code generation isn't stable or good enough?
That actually happened with packed structs, and then yeah, that can happen, I suppose. It did happen with packed structs, but as long as I ignore that, I have not seen anything out of anything weird.
Mm-hmm.
And I usually write tests and stuff. Yeah.
Okay, so through testing,
I'm not,
you are able
I'm
to
not
catch.
overly concerned.
Okay. Yeah, makes sense. I'm sure you're not the first person to have been burned, and nor the last by extracts. So we probably need to take a look at that system.
Yeah. I mean, you should just disable it until it works. Like right now, it's basically a landmine.
Mm-hmm. That's a good point. That's a good point. I think Andrew is sleeping now. He's on the wrong side of the ocean, so or I would say he's on the wrong side of the land, the one facing the wrong ocean, quote unquote. But I'm sure he's gonna take a look when he wakes up, and we'll see what he has to say. But yeah, I think that's something that it's worth checking after self-hosted is up and running. Next question. This one is from Nipsey. So, are all production so all the projects used in production static? Are they ever updated?
The first one is static. We don't have. It had to be static because the network is entirely isolated. And okay, let's say there's a bug, and we we would need to update. It's going to be really annoying going out to every factory and plugging and switching SD cards on every device everywhere. It's like really annoying. So it has to be static. Like it doesn't have internet connection or anything. So yes. For the unattended store thing, that was temporary. So that's over. So we do update it, but not anymore.
I see. Well, it makes sense. I mean, if the company is not paying for a support thing or whatever, if there's no extra development to be done, you're done, and that's it. That's actually, now that I think about it, one of the beauties of giving out binaries. I mean,
Yeah.
Yeah.
We do give out the source code too. Like here's a zip file. Not that anybody ever reads it, but looks nice.
Part of the documentation. It's like next to
Yeah.
the diagrams and stuff.
Here's some grossly outdated Zig code. Enjoy.
Well, you can sell it
No,
as a like pseudocode or something.
it's nice. But it does take like 20 minutes for me to fix it, like to make it modern Zig if I wanted to. It's not a big deal.
Okay, let me see if there's any questions outside of Twitch, like people in Discord. No, people in Discord are just passing around clips about you complaining about Rust. IRC is fine too. Okay, so I think we went through most of the questions. I'm actually looking forward to knowing more about the other projects once they complete and
Sure.
you give out a binary blob, a surprise binary blob to the customer.
Now we'll actually maintain it too. So we have a little tunnel to every device over the internet. So if we wanted to update, I can just press a button and it will update every binary.
I see.
So that's pretty convenient.
Yeah. So in the end, you had, I guess, mostly good time. I mean, could be worse. Still not perfect, but we're getting there, and it's doable. To be honest, while maybe generally speaking, it's a bit early to use Zig in production. I think you got one point super right, and I really share that opinion. And that is, if your point is just to create one binary and you have it and it works, you're done. It's fine. I actually had the same. So it's not really. Maybe it's not the same degree of production as you, but in my case, and maybe I'll talk about this a little bit later on my own side of the show, but I have a library on GitHub which implements a data structure, cuckoo filters, and it's compiled, it's there, and you download the release and it works and it does what it needs to do, and it's like 200 lines, so it's something very basic, but that's kind of the point. It's nice to have software that at one point you can consider completed, and once it's completed, maybe in the future there will be another architecture that you might want to compile it for, but at least it's
And I mean, if the customer tells us, "Hey, he wants a new feature," you get paid. It's development.
Makes total sense. So thank you very much. Is there anything? Any final words?
No, I'm fine.
Okay, then thank you very much, Jens. It's been a great pleasure. I'm looking forward to more talks from you about production, maybe other topics too. Up to you.
I may. All right. Thank you.
Bye-bye.